You're watching the Physics Classroom's video tutorial series on Newton's laws. The topic of this video is inertia and mass. There's two questions we wish to answer, and they are, what is meant by the term inertia, and how is inertia related to mass? Let's get started. Density, mass, volume, conductivity, elasticity, these are all properties of objects. Inertia is a property of objects also. Inertia, like all properties, describes how an object would behave. Specifically, what inertia describes is how an object behaves when a force is applied to it. Inertia describes the tendency of an object to resist a change in its state of motion when a force is applied to it. Inertia describes the tendency of an object to resist changes in its state of motion. But exactly what is meant by state of motion? Objects can be described as having a state of motion, and this includes information about its speed and its direction. Like if we observe this animation here, what we observe is that this car has a state of motion of being at rest. Its velocity is 0 meters per second. And this car has a state of motion of having a velocity at 10 meters per second to the right. Its speed is 10 meters per second, and its direction is to the right. Unlike this car, that has a state of motion of being described as being 15 meters per second to the left. Its speed is 15 meters per second, and its direction is to the left. This particular car here could be described as having no single state of motion. Its state of motion is constantly changing. It's slowing down, speeding up, and even at times, it's changing its direction. The state of motion includes information about speed and direction. I like to think of inertia as stubbornness to change. Objects want to keep on doing whatever it is that they're doing. All objects have this property called inertia, the tendency to resist a change in the manner in which they are moving. However, not all objects have the same tendency to resist a change. What is inertia? Well, it's the property of an object that describes its relative tendency to resist a change in the manner in which it is moving. What gives one object more inertia than another object? The answer is mass. Mass gives objects inertia. Mass, that quantity that describes how much stuff is present in an object, is the same quantity that describes how much inertia an object will have. Inertia depends solely upon mass and upon no other quantity. Objects with a greater mass will have a greater inertia. That is, they will have a greater resistance to changes in their state of motion. When you give a stationary object a push, you can feel its inertia, its tendency to resist a change in their at-rest state. For instance, if you look at the brick on the left here, giving it a small push causes it to fly. It doesn't have much resistance, and you feel it when you hit it with your finger. But if you look at the brick on the right, giving it the same type of push causes it to hardly budge from its at-rest state. It has considerably more inertia or resistance to change, and as such, it doesn't change its at-rest state as easily. And when you give these pushes to these two bricks, you can feel that inertia. Hey, if you're ever in the woods being chased by a moose, you can use its enormous mass to your advantage. You see, a moose has a lot of mass and therefore a lot of inertia, a tendency to resist a change in its state of motion. So all you have to do is make many sudden turns, and that more massive moose with its greater inertia will have a tendency to go straight while you evade the moose. Now that's physics for better living. The concept of inertia is often credited to 17th century scientist Galileo. He came up with the idea this way. He had two ramps and a ball that would roll down one ramp and then up a ramp on the opposite side. He would notice that whenever the ball rolled down the ramp, it would always roll up the second ramp until it got to about the same height. Now, if he changed the angle of that second ramp, well, the ball would roll a little bit longer, but it would still roll until it got up to the original height. And if he changed the angle of that second ramp again so that it wasn't a very steep angle at all, well, the ball would roll even longer, but it would roll until it got to the original height. It seemed the ball would always roll until it got up to that original height. So he reasoned that if you made that second ramp have a zero angle, the ball would roll forever trying to get up to the original height. The idea being now that an object in motion would continue in motion with the same speed in the same direction forever. We're going to do an experiment very similar to a Galileo experiment. We're going to give a cart a push along a track, but we're going to use a motion detector and measure the acceleration of the cart. Then we'll adjust the friction between cart and track and repeat trials for less and less friction. Here's our first trial with maximum friction. This is a speed versus time graph. If we find the slope of the line, what we're finding is the acceleration. It's negative 0.895. We're going to enter that into our table. We're going to adjust the friction to heavy friction, a little bit less than what we had, and try again. Here goes. With heavy friction, the slope of the line is negative 0.088. 0.808 is the acceleration. We'll enter it in the table, adjust the friction to a little less friction now, medium friction, and conduct the trial. With medium friction, the acceleration is negative 0.577. We'll enter that into our table, and then we'll try low friction trial. Here it goes. With our low friction trial, we notice the acceleration is getting less and less. It's negative 0.254. We'll enter that into the table and conduct a trial with very little friction. Wow, now that line's almost horizontal, and the slope of it is negative 0.053. Now we're going to ask the question, what would happen if we could have zero friction? If we could configure the system with zero friction and then begin to extrapolate the data that we see here in this table, what we might conclude is that with zero friction, there would be a zero acceleration. That is, start an object to get it going, and it would continue moving with a constant speed in the same direction, a zero acceleration. That's Newton's first law of motion. Isaac Newton is often credited with saying that if I have seen further, it is because I've stood on the shoulders of giants. And Galileo just might be one of those giants whose shoulders he stood on, because he took Galileo's idea of inertia and extended it to his first law of motion. He said that an object at rest stays at rest, and an object in motion continues in motion with the same speed and same direction. In other words, objects want to keep on doing whatever it is they're doing. They have inertia, the tendency to resist changes in their state of motion. Here's the take-home messages. Inertia refers to the relative tendency of an object to resist changes in its state of motion. While all objects have inertia, not all objects have the same amount of inertia. It's mass that determines how much inertia an object has. More massive objects have more inertia than less massive objects. It's at this time in every video I like to give you an action plan, a series of next steps to make this learning stick. Before I help you out with an action plan, could you help us out? First of all, could you maybe give us a like if you enjoyed the video and subscribe to our channel, and once you do, maybe you can tap on the bell and get notifications when new videos come out. Finally, there's a place below where you can leave a question or a comment. Thank you. Now for your action plan. First, at our website, we have a section called Concept Builders. And one of the concept builders, called Changes of State, would be a great follow-up to this activity. We have a link to that and all the resources in the description section below this video. Second, we have a Minds on Physics app, actually a series of them. And you want app number 2. And on that app is a module called the Newton's Laws module. And Mission NL1 is a perfect follow-up for this activity. But if you'd like more of a game-like follow-up, you might go to our website to the Physics Interactive section and try Racetrack. Again, there's a link to that down below. My only comment is, you better watch your speed. Finally, we have a tutorial on our website. The tutorial is a great place to use as a reference. You can go to the Newton's Laws chapter and check out lesson number 1. There's a page there called Inertia and Mass, just like this video. Whatever you do, we wish you the best of luck.